Okay, good day, Math 102. Today I will talk about section 7.7. I'm sorry I recorded this video before, but it was without sound. So I'll just go over it now. In this section we start numerical integration. And when are we going to use numerical integration? We will use numerical integration if we are dealing with definite integral that is either hard to find, to evaluate, or we need just the approximate value of that integration. For example, look at this example number 1. If you look at this example, it asks to approximate this integral, which seems to be a long and lengthy one if we try to evaluate it, but he wants me only to approximate. And he gave me the number of n, which is 10. Let's see the formulas that I will use to approximate this one, and then we will go through this example. The first formula is called trapezoidal method, okay, and the full explanation, please refer back to the book. You will find a very nice explanation in the book. You can read it for your reference. Refer to the textbook for more details. For now, what's trapezoidal method? You start with integral from a to b, f of x. First step, you need to find something we call a delta x. What is delta x? It is just b minus a over n. N will be given in the question. B is the upper limit, a is the lower limit. And you find this delta x. After you find delta x, you will approximate it in this way. Integral from a to b, f of x dx equal this number over 2. And then you go to your function and you evaluate it at those little numbers, x0, x1, x2, up to xn. And then there is a 2 up here. So it is x0, x1, x2 to xn. We will see how we will find them in a minute. And then there is number 2 in front of each one of these. Or usually you don't need to find f of x1, as you will see. It is just y0 plus 2y1 plus 2y2 plus 2y3 plus 2yn minus 1 plus yn. Let me go to the example and show you how you will find it. In this particular example, first step, we need to find delta x, which is b minus a over n. So it is 2 minus 1 over 10, which is 0.1. That is the number. It is just 0.1. The next step, you will have to make a table. Table of xi and table of yi. The table of xi, you should start with your number here, which is a. So you start with a, and then you start adding delta x to this a. So you start with 1, you add 0.1, you get 1.1, you add 0.1, you get 1.2, take 1.2, add 1, you get 1.3, take 1.3, add 1, and so on. Where are we going to stop? Automatically we will stop at b. This is b, remember, which is 2. The next step, you substitute x in your function to find the y. So if you substitute 1 here, you will get 0. If you substitute 1.1, you will get this one. If you substitute 1.2, you will get this one. 1.3, you get this one, and so on to the end. And finally, we plug in the formula, which is 4, 4, 4, 4, 1. Okay, just let me here show you. This is by mistake. This is not 2. This should be 4. All of those should be 4. So plus 4y1, 4y2, 4y3, 4y1. And this is the formula how we use the trapezoidal method. The other method is exactly the same, which we call it the Simpson method. And this is we use it when n is even. it will give me a better approximation most of the time. And it's exactly the same. The only difference is you don't divide by 2, you divide by 3. And those number 4, 4, 4, 4, now they become 4, 2, 4, 2, 4, 2, 4, 2, and so on. The first and the last is without a number, and then you start 4, 2, 4, 2, 4, 2. And you can see it here in this example. Down here, it's just you need to use 4, 2, 4, 2, 4, 2. The one with the even, y2, y4, y6, you use 2. The one with the odd, 1, 3, 5, you use 4. Or you can just memorize it as this: 1, 4, 2, 4, 2, 4, 2, blah, 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 4, 1. So this is the numerical integration. Please go to the book, solve the exercises to get more practice. Let us know if you have any question. Thank you.